to begin understanding how water shapes the landscape that we live in, it's first important to understand how it moves that material around the landscape. So we're going to start this out by looking at flow characteristics of streams. And we're going to go through some of the physical processes that are involved to begin with. And then what we'll do is later on move into a specific example of how these physical processes actually have shaped the environment, or a specific environment. And in particular, we're going to be looking at the coastal plain of South Carolina. So to start out with, it's important that we understand what actually controls the velocity of water. So velocity is impacted by three things. First of all, it's impacted by the slope of the channel within which it's moving. It's also influenced by the depth of the water. And finally, the third thing that influences the velocity of water is the roughness of the channel. And we'll talk about each of these things in turn and how each of these things impacts velocity. And they all act in slightly different ways. So first of all, what I want to do is start thinking about what does velocity, how does the slope or the gradient of the channel impact velocity? So think about this for a few minutes, and it's pretty self-evident. The steeper the slope is, the faster the water is going to move down that slope. So this is fairly straightforward. If you have a marble on a table and you lift the table up, the faster, or one end of the table up, the marble was going to move faster down the table than if you only had it at a slight angle. The same is true for water in channels. So the first thing to recognize is that velocity increases with slope, with channel slope. So that's the first thing that we need to take into consideration. The other thing then we need to look at is depth. And so how does depth actually affect water, or affect the velocity of water on a landscape? And it turns out that it's in the same basic way that channel slope does. So if you increase the depth of water, it tends to move faster. So velocity also increases with depth. Now, roughness is essentially is exactly what it sounds like, how rough the channel is. And think about this, and think about some experiences you may have had as a child, but going down a water slide. If you want to go down a slide that's in someone's backyard where they have a pool, and there's no water that's running down the slide, and you try to go down that slide, you don't move very fast. You tend to sort of stick onto the slide itself. But if you put water on the slide, what you're doing is essentially reducing the roughness of the slide, and you slide right down it. So this is the same idea with river channels, except for roughness is not necessarily only determined by whether it's wet or dry, but the kinds of things that are in the river channel. So depending on the amount of rock that's in the river channel, the substrate over which the channel is through, and also things like vegetation, all of those things can increase the roughness of a channel. So velocity actually decreases with increased roughness. All right, so now what we can understand the three basic controls on the velocity of water in a channel. The next thing that I want to do is then sort of look at how each of these things play off of each other. So what happens, which is more important, velocity or slope? We're not going to worry about roughness too much here because it's not the most important one affecting velocity. The ones that we're going to concentrate on are going to be velocity and slope. So if we move on from this, then let's take a look at two different situations. So first of all, let's look at mountain streams. And we're going to compare it to big rivers. So these are two things that are essentially mutually exclusive. Big rivers tend to be in low-lying areas, and mountain streams are in high areas with high slopes. So let's go through and look at two very specific examples. First of all, the mouth of the Amazon, and then a mountain stream, the Grand Canyon of the Yellowstone. First of all, what we'll do is we'll take a look at what the gradient of these two rivers or streams are. So if we look at what the gradient is of the Amazon, it's relatively shallow. So it's in the neighborhood of 1 to 2 inches per mile. So what this means is that for every mile that the Amazon travels, it goes down about 1 to 2 inches in elevation. So not a very steep gradient at all. Now, if we compare this with the Grand Canyon of the Yellowstone, which is the Yellowstone River as it goes through parts of southern Montana and northern Wyoming, what we have there is that the gradient is considerably steeper. So in this case, the gradient is about 200 feet per mile. Significantly different than what you would expect at the Amazon. Now, the other characteristic that's important here is the depth of the water. And the depth of the water in these two locations varies a lot. So the depth of the water in the Yellowstone is actually fairly shallow. So the depth of the water of the Yellowstone River as it goes through the Grand Canyon of the Yellowstone is in the neighborhood of 1 to 2 meters deep, so not very deep at all. Now, when we compare that with the depth of the Amazon River, it's at about 50 meters deep. So remember, the Amazon River, a giant river that's draining a huge portion of South America, it's navigable by large ships. So 50 meters deep is pretty deep water for a river. And the mountain stream in the Yellowstone, 1 to 2 meters, not all that much. So the question then becomes, which of these two do you think has the higher velocity? So what we're really trying to get at here is which of these is more important? Is depth more important, or is velocity, or is the gradient of the stream more important? And the answer to this we can determined by looking at what the measured velocity of these two streams are at those locations. So the Grand Canyon of the Yellowstone has a velocity of about 1.25 meters per second. And the velocity of the Amazon is about twice that, at about 2.5 meters per second. So what we see is that the depth is actually much more important to the velocity of the water than is the gradient of the stream. So the gradient of the stream in the Yellowstone, very steep, 200 feet per mile. The depth only about 1 to 2 meters, and the velocity is actually relatively slow at 1.25 meters per second. Compare that to the mouth of the Amazon, where the depth is 50 meters deep, and the gradient is 1 to 2 inches per mile, but the velocity is twice that of the Yellowstone River. So the key thing to recognize here is that what we have is two factors, both of which influence the velocity of the river, and which of the two of them is the more important. So let's answer the question of where does water move the fastest? In this case, what we're doing is we're looking at one area that at a much smaller scale. So initially we were looking at the differences between two rivers that had two different characteristics of depth and velocity. But now what we're doing is looking at a single stream, and within that stream are there particular places where the velocity of the water is different than at other places. So this is where roughness is actually going to come in. So eventually we'll sort of get to that point, but first of all, let's draw a cross section of a river. So if this is the top of the river, and then this is the bed of the river, what we're looking at is sort of a cross section where we're looking straight on into the river. So imagine that the water is flowing toward you out of the screen along the bed of this river. Okay, so where in the river does the water move the fastest? It turns out the place in the river where water moves the fastest is right about here. So it's just below the surface in the center of the stream. So the question then is why does this happen? Well, let's look at a velocity profile of how this is working. So if we were to look at lines of equal velocity, what they would tend to do is they would look something like this. And we'd see things that look just like this. So what we would find is that the fastest water is moving right below the surface near the center of the stream. So the question is, well, why does that happen? Why is it that the slowest moving water is located here? Well, the answer to this is that it has to do with the roughness of the stream bed. So there's friction that occurs between the stream bed and the water itself. And so the place where the water is going to move the slowest is where the friction is greatest, which is going to be right up close to the bed itself. So the further you get away from the bed and the closer you get to the surface is where you're going to have the water moving most quickly. The reason that it's just under the surface is because there's also some friction between the air and the water itself. So that's more than the friction between the water and water. And so the result of this is that we have this fast-moving water that occurs right below the surface of the stream. All right, so why does that matter? Why does the position of or the location of that fast-moving water in a stream, why does it have any impact on things? Well, the reason for this is that it has to do with how streams move. So if we sort of shift our perspective from looking at a cross-section of the stream, where we're looking straight into the stream as the water flows towards us, to taking an aerial view of the stream. So imagine a stream that does something like this. So we have a bend in the stream, and the water is moving in that direction. So if that's the case, then what we would do is we would expect that this fast-moving water would be sort of right here in the center of the stream, and it would continue that way, and we'd have slower-moving water over at the edges. So in here, we would have slower-moving water, and we'd have that fastest-moving water that would be coming like this until it hits the edge of the stream. Once this happens, it's going to ricochet and it's going to start going in this direction. And again, we're going to have the fast-moving water in the center, and we're going to have relatively slow-moving water off to the sides. Okay, so we have slow-moving water near the sides, and we have fast-moving water that is in the center. Well, okay, so now we can see how the water itself is moving around in the stream, but why does this matter? And this is where it has to get to the point where we understand that the reason we care about the velocity of the water is because of the impact that it has on both erosion, transportation, and deposition. So we need to now understand the concepts of erosion, transportation, and deposition. Now, erosion is essentially the breaking down of material or the picking up of material and carrying it away. So transportation is actually the moving of the material itself, and deposition is dropping it off. So a lot of fluvial geomorphology can be summarized into a nutshell, and what we're interested in is how water picks stuff up, how it carries it, and how it drops it off. And many of those things are related to velocity. Now we'll go over a figure in a few minutes to show what the impact of velocity is on all of these things in particular. But before we do that, I want to think about this one figure a little bit more in the abstract. The important thing here to recognize is that the faster the water moves, the more material it can carry, and the heavier material it can carry, and the more erosion it does. The slower the water moves, the less material it's capable of carrying, and the lighter material it will carry. So what happens here is if we see where this fast-moving water is, we see that it's actually hitting the channel at about that location. In contrast, on the other side of the river, we have an area of slow-moving water around this edge here. So what's happening is that this area, I'm going to change the color of the pen, so this area here is an area of deposition. And this area here,
I found this on the web for here, is an area of death. Check it out.
so we have this area here that's an area of deposition, and we have this area here which is an area of erosion. What this means is that over time, we're going to see continual changes in the position of the river. And so what will happen is that the banks of the river are going to migrate because we're having areas over here that are being eroded. So this is going to move in this direction. And we have deposition that's occurring here. And so the channel of the river will do something like this, and we'll get a bend that looks like that. So the ultimate result of all of this is that we have the movement of the river in that direction. And this is all caused by the differential effects of velocity on the river itself. So this is why many rivers, especially in low gradient environments on coastal plains, meander. And you'll see these real curvy types of river systems on the landscape. And this is all driven by the velocity of the river and the impact that the velocity has on erosion, deposition, and transportation of material.